Dear students, I welcome you all to the virtual lab class. In this part, I am going to explain the spectrometer wavelength determination using grating. The aim of this experiment to calculate the wavelength of prominent lines of the mercury spectrum using normal incidence method. Mercury emits white light. When mercury passes through diffraction grating plate, it diffracts into several colors like violet, blue, green, yellow, etc. We are going to calculate the wavelength of all these prominent lines. So this is the aim of this experiment. The apparatus required for this experiment are spectrometer, plane transmission grating, reading lens, sodium vapor lamp, mercury vapor lamp, spirit level, etc. Especially, we need sodium vapor lamp in order to calculate the number of lines per meter in grading plate and the mercury vapor lamp to determine the prominent wavelength of all the colored lines. And the transmission grading plate, we need 15,000 LPI, which means 15,000 lines per inch grading plate for this experiment. And the reading lens is used to see the measurements. Today, while taking measurements, we will be using this reading lens. So these are the apparatus required. The formula used to calculate the wavelength of prominent spectral line is lambda equal to sine theta by n into n, and the unit is meter, where theta is the diffracting angle which we will be measuring from the spectrometer, and small n stands for number of small n stands for order of spectrum, where here we are going to focus only the first order spectrum. We are not going to focus the second order. So in all the cases, the small n value will be equal to 1. And capital N is the number of lines per meter in grading plate. So the capital N value, we do not know what will be the value of capital N, which means the number of lines per meter in a grading plate. So what we do, we can calculate the capital N in first part of the experiment. That capital N can be substituted here to calculate the wavelength. And to calculate the N value, number of lines per meter in a grading plate, we need a known source, which means the wavelength of the source should be known. So we use sodium wavelength here. Okay. So using a sodium source, we can able to calculate what is the number of lines per meter in a grading plate, and then we can able to calculate lambda. In this formula is obtained from the diffraction grating formula. We know that n lambda is the condition to get a bright fringe, which is equal to d sine theta, where d is the distance between the two transparent lines or opaque line, and this d can be obtained as 1 by n, where n is the grading constant or the number of lines per meter in grading plate. So by substituting this d value there, we can get these formulas. And the expansion of the symbol, I told this theta is angle of diffraction, which is measured in terms of degree. This angle of diffraction is obtained from the spectrometer instrument. N is the order of diffraction. I told here we focus only the first order spectrum. The small n value is equal to 1 and no unit. And lambda s is the wavelength of sodium light. Wavelength of sodium light, which is the wavelength of known source, right? And we know that sodium emits two lines, D1 line and D2 line. The D1 corresponds to 5890 and D2 corresponds to 5896. We cannot see both the spectral lines distantly using this apparatus because the spectral width is very small, 5890, 5896. The difference is 6, so very small. So we cannot see those two spectral lines distantly. What we can do is we can take the average of those two values, 5893 into 10 power minus 10 meter. This wavelength can be used. And lambda is the wavelength of the prominent lines in mercury spectrum, which we are going to determine. Thank you.